So we begin here. There's fundamental trigonometric identities. These are identities that you really want to remember as much as possible. I will give these to you on the test, okay? But I really want you to remember these as much as possible. Number one, sine of theta is equal to 1 divided by cosecant theta. Everybody agree? Those are reciprocals of each other. You also know that cosecant of theta is equal to 1 over sine of theta. And give me another one. Cosine of theta is equal to 1 over secant. Secant is the reciprocal of cosine. And so 1 over cosine, whoops, sorry, I'll let it take this. So we also know that secant is equal to 1 over cosine. What are the two I've left out? Right, so we have tangent of theta is equal to 1 over cotangent. And cotangent of theta is equal to 1 over tangent. They are reciprocal identities. Are they okay? All right. Quotient identities. These mean I can divide. Do you remember what sine of theta divided by cosine of theta is? Y over x, which is the same as tangent. What if I were to flip that? Cosine of theta divided by sine of theta. Not tangent, but cotangent. And now we get to Pythagorean identities. Okay? Are you ready? Well, I really like it, but I know sometimes it's not everybody else's favorite. So, you can move to the front of your notes where you can write this down so we get a little bit extra space. X squared plus y squared is r squared. What is that? Remember? It's an equation for a circle. It's actually also the Pythagorean theorem, isn't it? You just switch out the x and the y with a and b, and switch out r with c. It's the Pythagorean theorem. That's all it is, right? In the unit circle, what's the length of the radius? 1. So we also have this. X squared plus y squared is 1. Are you with me? In trigonometry, in the unit circle, we say x is the same as what, and y is the same as what. Hint, it's somewhere on this page. X is the same as cosine, and sine is the same as y, right? Yeah, so those are x and y. So sine is y, and cosine is x, and tangent is y over x. Remember that? So watch what I'll do here. I'm going to substitute, instead of a y, I'm going to put it in a sine. And as I write sine of theta squared plus cosine of theta squared is equal to 1. In mathematics, we like to write this a little bit more shorthanded. Instead of writing it sine of theta with the parentheses squared, here's the way that they write it. Sine squared of theta. That means you don't square the angle, you square the operation. So first I take sine of the angle, and then I square it. That's what that means. Plus cosine squared of theta is equal to 1. That's our very first trigonometric identity for the Pythagorean ones. So, as we move over here, we're going to write down 3 of these. The first Pythagorean identity is sine squared of theta plus cosine squared of theta is equal to 1. If you leave trigonometry and move on to another math class someday, and somebody said, oh, you took trigonometry, can you tell me something that you learned from it? Hopefully you'll be able to talk about SOHCAHTOA, right? Solving right triangles. That's a big deal. But the second big deal is this. You should know that sine squared plus cosine squared is 1. You should know that tangent is sine over cosine. Those are fundamental things that are really important. I'm going to show you how to come up with one more, and then we'll just write the third one down without doing any work. You don't have to write this down, but if you'd like to, you can. I'm going to come up with a new formula, and I'm going to divide through by something. I'm going to divide through by cosine squared. That's a legal step to do, and we're going to see if you can help me uncover the new formula. What is sine divided by cosine? Tangent, right? And so sine squared divided by cosine squared is tangent squared. What's cosine squared divided by cosine squared? 1. What's 1 divided by cosine? Not cosecant, but secant. So this is a second trigonometric Pythagorean identity that we can use. And these are by far and away the most common identities that you would use. Sine squared plus cosine squared is 1, and 1 plus tangent squared of theta is equal to secant squared of theta. And we could do the same thing by dividing by sine squared, and we would get 1 plus cotangent squared of theta is equal to cosecant squared of theta. Those are our 3 options. We're going to make use of them. There's one more piece that we need to learn. Just put it right over here. I divided it up into 4 quadrants. Quadrant 1, 2, 3, and 4. Is sine your x value or your y value? Sine is your y value. So is sine going to be positive or negative for the first quadrant? Positive. And so will its reciprocal. Is cosine x or y? X. So is cosine positive or negative in the first quadrant? And so will its reciprocal. What is tangent in terms of x and y? Y divided by x. So will it be positive or negative? Positive. All of the 6 functions are positive in the first quadrant. All are positive in the first quadrant. I move to the second. as you move to the second, is y positive or negative? So will sine be positive or negative? Sine will be positive. How about cosine? Why will cosine be negative? Because x is negative and cosine is x. Tangent is y divided by x. Will tangent result in a positive value or a negative value? Negative value. I'm writing the positive ones in blue and the negative ones in red, so I just write tangent. We move to the third quadrant. Sine is y, so will it be positive or negative? It will be negative. Cosine is x. Will it be positive or negative? And tangent will be y divided by x. Will that result in a positive or a negative? Positive. And I move to the fourth quadrant. Cosine or sine. Sine is your y value. Will it be positive or negative? Cosine is your x value. Will it be positive or negative? Hi. Missed you. And tangent, will it be positive or negative? Because you have a negative divided by a positive, it will be negative. Now, this is part of what we need to remember. And I will give this to you in notes for the test, but here's a way that some students remember it. All of the functions are positive in the first quadrant. S is for students, and it's for sine. Sine and its reciprocal are positive in the second quadrant. T is for take, as well as for tangent. Tangent's the one that's positive in the third quadrant. And C is for calculus. All students should take calculus. Someday, right? I don't see any smiles. It's pi day. I say take calculus. Jasmine brought pi. I say you guys should all take calculus, and you give me a scowled look. So that's all right. Okay, so you can see here, C stands for calculus and cosine. T stands for take and tangent. S stands for students and sine, and all is for all of them. So if you remember this acronym, all students take calculus, that can help you identify in which quadrant they'll be positive and negative. Okay? So let's try our very first basic example. Okay, we're just going to try to get through 2 today. Okay, that's it. Some heavy lifting. Okay, sine of theta is equal to negative 4/5, and theta is in the third quadrant. Find the values of the 6 trigonometric functions given the following information. Anytime you see that, you write down all 6. Sine of theta, cosine of theta, tangent of theta. Cosecant of theta, secant of theta, and cotangent of theta. You tell me, okay, you tell me, what is the exact value of sine of theta? What does the problem tell us? Sine of theta is negative 4/5. Here's one of the very common answers I get for this problem on the test. Okay, that's the very common answer I get on this test. IDK, And I'm pretty sharp. It stands for I don't know, and that's great. Okay, but I'm going to tell you that if you don't write down -4/5, you're not trying hard enough. Would everybody agree? That's bottom expectation, right? Now we're going to up the ante just a little bit more. I'm going to say, okay, you got the -4/5. I think you could tell me what cosecant is. Because what's the relationship between cosecant and sine? They are reciprocals. So my argument to you is that on the test, you could get 2 out of 6 points for this problem pretty quickly. What do you think? I mean, that's pretty straightforward, isn't it? So at least write that, okay? And then I won't be super mad. But if you write IDK, I'm gonna break out the red pen and just start marking stuff around everywhere. I get so angry. I'm like, oh, don't do this. Okay. So now what we need to do is we need to find these other pieces. And I'm gonna focus on cosine. And I have a special formula that I can use. And since I'm running out of room over there, I'm going to put it right down here in all your races. So just kind of make room where you can. But I'm going to use a special formula. I'm going to use sine squared of theta plus cosine squared of theta is equal to 1. I pulled that formula from up above, right? I know what sine of theta is. So how do you think I get sine squared? What do you think I do to that value? I square it. When you square something, it will always turn out positive. What is -4 times -4? 16 over 5 times 5, 25. And instead of writing the number 1, I'm going to write it so it has a denominator of 25. What fraction is the same as 1 but has a denominator of 25? What do you think I do to solve for cosine? I subtract 16 over 25. And I get cosine squared of theta is equal to, what is 25 over 25 minus 16 over 25? 9 over 25. Now what do I do to both sides? Square root. Square root of cosine squared is just cosine. What's the square root of 9? What's the square root of 25? 5. And when I take a square root like that, I have a positive and a negative. So we've done a great job right now of identifying that's either positive 3/5 or negative 3/5. Let's look at our quadrant. It says we are in the third quadrant. Is cosine going to be positive or negative in the third quadrant? It is negative. So therefore, -3/5 is the answer. What about secant? Reciprocal, which would be -5/3. What's that? Oh. Now I have one last value to find. If I could find tangent, cotangent would be quite simple. And so you have a few options. You could either use this formula, 1 plus tangent squared is secant squared, or you could use sine divided by cosine as tangent. And I'm going to choose to use sine divided by cosine as tangent. What is your sine value? Divided by, what's cosine? And when I divide, I should multiply by the what happens? So cotangent is 6. What do you think? Okay, what we want to do today is, and again, we're taking 2 days with this. We'd like to do one more problem. I'm going to give you a worksheet where you're going to be able to try some of these easier problems. Tomorrow we'll practice more, but you just, I'm going to, yep, the 2 problems I'm doing are the easier problems. I've written 2 different worksheets, an easier worksheet and a harder worksheet. I'm just giving you guys the easier one. And I think we can do it, okay? I saw a lot of people not get this right the first time we went through it. But about the 3rd, 4th time we went through it, a lot of people started to get it first quarter. So I think that you guys will come around to this, okay? So let's try another example. And then we'll have you try one on your own, and we'll come back tomorrow and revisit it, okay? Cosecant is -2. Find all 6, and write down all 6. Sine, cosecant, cosine, secant, tangent, cotangent. Which one up here do we know? Cosecant is -2. All right. Avoided that IDK, right? So -1/2 would be sine. The sign stays the same. The negative and positive stay the same. It's just they flip upside down, okay? All right, so I've got that much. What should I do now? I'm going to pull up my handy-dandy formula. Sine squared of theta plus cosine squared of theta is equal to 1. If I square something, it will become positive. So I'll use the negative with the top. What's -1 times -1? 1. What's 2 times 2? 4. Plus cosine squared is equal to, instead of 1, I should write 4/4. How do I solve? What do I do? Minus the 1/4. And I get cosine squared of theta is equal to 3/4. Now what? Square root of cosine of theta is equal to, you have to write square root of 3. You take square root of 4. What do you get? 2. And it's either plus or minus. So we should figure that out right now. Well, let's look at what this says. It says cosecant is -2. That means that sine has a negative value. You tell me, which quadrants does sine have a negative value? Yeah, as you look here, in the 3rd quadrant and the 4th quadrant, sine has a negative value. It says cotangent is less than 0. What does it mean for something to be less than 0? It's negative. So cotangent is negative as well. Which quadrants is cotangent negative? 2 and 4. So where's the overlap between those 2 conditions? Is it the 1st quadrant, 2nd quadrant, 3rd quadrant, or 4th quadrant? That's the overlap between those 2 conditions. 4th quadrant has both of those situations. Has sine or cosecant is negative and cotangent is negative. That's not the case in 3, only sine's negative. It's not the case in 2, only cotangent is negative. 4th quadrant is where both of those things happen. So I am working in quadrant 4. If I'm working in quadrant 4, is cosine positive or negative? It's positive. So it will be positive root of 3 divided by 2. Cosine is positive or negative. We said we're working in the fourth quadrant, and cosine is positive in the fourth quadrant. How about secant? What do I have to do to get secant? 2 over the root of 3. Uh-oh, can I leave the root of 3 in the denominator? So what do you have to do? Top and bottom by the root of 3, and we get 2 roots of 3 over 3. So I've got 4 out of the 6. And to get the last one, I'm going to take sine and divide it by cosine. How do I divide those fractions? Multiply by the reciprocal. What happens? Can I leave the square root in the denominator? But hold on. I'm going to save you guys some time here. What would I do to this to get the cotangent value? You flip it, and you just get negative root of 3, right? Easier to look at that and do it now than it is later, trust me. Okay, how do I change this? Multiply top and bottom by. I get negative root of 3 over 3. So I have 1 value, 2 value, 3, 4, 5, 6. Kind of involved, huh? It's going to take 2 days, you guys. If you feel a little confused, it's all right. Tomorrow we'll feel better. Okay, I promise. So I'm going to hand you a worksheet, and you're not going to complete this worksheet overnight, okay? I just want you to try one problem, and we're going to pick it back up tomorrow, okay?